Hey, hi everyone. Welcome back to the session of joining dataset using raw file operations. My name is Kunal Gautam. I work as a principal architect for one of the MAN companies, have 16 plus years of experience, have worked across 50 plus customers across 20 plus countries, co-founded a startup known as Windex in the domain of e-mobility, and have spoken at multiple Hadoop and big data slash AI conferences around the globe. So just a quick recap on the theory part of it, that we have been given two files, user country, country capital. User country is like a small file. The reason being the number of countries are limited in the world, while there are 7 billion people on the planet. And what we have to do is we just have to join them and create an output, user country capital. This is pretty much doing an inner join in your database. There are three options. First is if there's a possibility, imagine you have a lot of RAM. What you can do is you can pull both of your data inside RAM and save that in a hash map, or in the Python world, it's a dictionary. And you can iterate through the user comma country dictionary or hash map, do a quick lookup in the country capital and generate the output. The second option is you go ahead and read only one line at a time from user country, country capital. So you're reading user country, then you are going to country capital, iterating line by line in the country capital file. Wherever you find a match, you create an output. And you do it with each and every line out there. What it means is for every entry in user country, you will be iterating the country capital file always. The good part of this is the memory footprint is minimized, but at the same time, the disk it's super slow, given that you are iterating one line at a time. The most optimized, or let's say the way generally it happens. So the country capital, which is a small data set, that's cached, or let's say that's saved into a dictionary, which is located in the RAM. Now you take country capital because that's a huge file, that's a 100 gig file. So you cannot pull the data in memory. What you can do is now you read country capital one at a time, do a quick lookup in the dictionary, and then you are able to uh, get the output. So now, and the beauty of this is third option will never crash. The second option will never crash, but it's highly unoptimized, given that for every entry in the user capital, you have to iterate through the country capital map. The first one will definitely crash if your user country data file is the size of that is bigger than the RAM of your laptop. Why is this important? Because start correlating whenever you do a what is that? Inner join in your database. Sorry, this is exactly what's happening. So the server database code is listening on a port. You connect through a workbench. You say create table, insert data table. You do a join. What's happening is the server code is written in C++. So what's happening is SQL goes, and just do understand, SQL is not a language that is C++ understand. So what will happen is there is a parser which parses the SQL statement, and it is able to figure out what to do. So there's a physical plan and a logical plan created. And based on that, it goes to basic file operation to provide a join, group bys, filter operation, all that you can think of, like in terms of SQL, they are done using basic file operation. Although this is a very simplified version, but that just gives you an understanding that, hey, even in Spark, MapReduce, Hive, there is a converter. You write a SQL, somebody converts that to MapReduce, somebody converts that to Spark. Because Spark, MapReduce, Hive, all that they are doing is they are providing you the set theory operators. So that's how the translation happened. Let's go for a quick code deep dive into it. So a quick one. First of all, I have created a class known as country capital. Again, beauty of this is just start thinking this in terms of, hey, I have a country capital. In the file, it could be something like country, comma, capital, right? Given I have provided the understanding that the data is given in the JSON format. So in my file, I need to save JSON. When I convert that to an object, this is how the object looks like. So first of all, this is from object-oriented programming. You can realize how a file can be abstracted as a class to begin with. For all my folks out there who are using Python, please ensure that you code this in Python so that you understand if a file is there and I have to represent that as a class, how can I do it? So in the comma separate value, every column that you see there becomes the instance variable. So in my JSON, there are two variables, or let's say two keys are there, right? One is country and the other is capital. I have used Google library JSON. What JSON does is it can convert your class to a JSON. And at the same time, it also provides you the ability from the JSON, you can get back the class. So just look at these two statements. So this is converting the object to JSON, and then you can write it to a file. Or if you're reading from a file somehow, you read a JSON and you can convert this back to a class. How is this? To get a JSON, this is the type or the class definition. And what is the output type of this function? It is a country capital class, which is this one. Right? Others are just the setters and getters. So these my instance variable. These are the setters and getters. In the main function, I have just written a small, not a test case, just to verify it's all working. So you can create an object. From the object, you can get a JSON, and then you display it on the screen. Right? So if I just run it quickly, this is how it will look like. Right? So India, Delhi. So country is India, capital is Delhi, and this is a valid JSON. Similarly, I have created another class, user country. Again, quick understanding. This is an abstraction of the user country file as an object, or sorry, as a class. So again, from the object-oriented perspective, in the JSON of user country, user and country are the two keys of the JSON. So that's given an instance variable. You have the getters and setter, and then you have the two functions. Because I had used the JSON lib, which you can see here, it provides you the ability to convert the JSON into convert the object into a JSON. So object to JSON is the function. Secondly, what I have done is I have abstracted out, given a JSON, can you convert that back to a class? So this is the string to or JSON to class mapping. This is quite a famous one. Similarly, in Python, you have the simple JSON. JSON dumps, JSON.loads. It pretty much does the same thing. All right, now a small test case for this. Let's go ahead. Now the beauty of this. So forget about what code I have written here. Let's just go through the flow and then go for a deep dive one by one. So as I have mentioned, we will first do this part. We'll assume that my data can be loaded into RAM and I want to create the output. Let's see what's happening. First of all, I create two hash maps out there. The first hash map is country capital, second hash map is user country hash map. Just keep in mind, this country capital hash map will always be very small, given that there are approximately, whatever, in the order of 200 to 300, the number of countries range in that. If you look at the size of this data, this will be maybe a 1 MB of data. Your JVMs generally nowadays on the modern computers, you at least give like a 10 GB or 15 GB JVMs, right? Like I'm saying, even for a very simple, small use cases or databases, you give even more, like 32 gigs also, it's possible. Out of the 10 gigs or 20 gigs, you are just consuming 1 MB of data. So this data is nothing. This data, the memory footprint of this data is very small. Just keep in mind, folks, that I just want to call out that, hey, this data structure that you have, it only has footprint on the RAM. This is not on hard disk. So if let's say if somebody switches off my RAM, this data structure will be gone. Right? That's the reason people generally also use the term cache for them. That hey, this data structure is there, and that's how my cache is. Because first of all, if you have this mapping on the RAM, you do any operation on this, it will be lightning fast. Two reasons. First of all, your RAM, they are not having any moving parts. Your hard disk has a moving part. If it's a hard disk drive, not the SSD one. The hard disk drive, first of all, it has a moving part. That's the reason the I/O, the throughput of your hard disk is quite low as compared to a RAM. A RAM is maybe 1000x or maybe like 10,000x faster as compared to your hard disk. So it means that whatever operation you do here, it will be lightning fast, almost at the speed of electricity. That's what I mean to say. So now let's do what we are doing. First of all, we have to arrange our data. So what we are doing is we are going ahead. This is the class that we have defined. There are a couple of functions there. I'll go through it, but just keep in mind, this is the class this is a custom class that we have defined. All that we are doing is we are saying that first of all, for the country capital, create a folder structure. What we have done is I have already started arranging my folders in a database format. So we are saying that first of all, there's a /tem. In the /tem, there is a /demo db1. And whatever data or country capital will be there, it will be stored underneath it. And how it will be stored? So this is my base path, right? You can see here, this is my base path. In my base path, first of all, I create a database. I leave the name as database itself. And then I have a folder known as country capital. So this is the folder structure to begin with. This is not my data. This is the folder structure. Inside the folder structure, cu-cap under txt is my file name. I have just abstracted everything, all the steps as a class, and that's how this file gets created. Next, what we do is we generate the data for country capital randomly, right? Next, what we do is now we read the data back. So this was like artificial data generation, right? Now what we do is we simply say, hey, can you generate the country capital data? And once you have generated, the data goes and gets saved here. Now I read this data, and now you can see here, I am converting that as an object. So country capital, JSON to object, whatever we saw in the previous class here. Yes, JSON to object, this function we called. And we got back the country capital class. We are, because we have abstracted out the file as a class, all we can do is we can just go here and say, in the hash map, this is my key, country is my key, sorry, and capital is my value. Similarly, I go ahead and create a user country. I read back the generate the random data, and I go ahead and I do the same thing. I create a user country, and in the user country hash map, here it was user capital hash map. Here it's a user country hash map, and I again put in that hash map or dictionary in Python the key as the user and the value as the country. So now for this hash map, what is the key? If I want to do a quick lookup, I give the country name, I'll get the capital. In this hash map, what is the key? If I give a user, I get the country. This country I can leverage to do a lookup from this hash map and enrich my data, and I get user country capital. So what we can do, just look here. What we are doing is, first of all, we are iterating through the user country hash map, and I'm getting the key, which is the user. I get the capital by just doing a country hash map lookup, and for that capital, I again do a lookup from the country capital hash map. And that's how I'm able to get user country capital here. Again, just from mental model, you generate random data for country capital, user country, save it on a file, then you read it back again, get back the objects, save the like from the object, you populate two hash map, you iterate the user country hash map or dictionary, you do a lookup in the country capital, and you're able to generate this data. This is how you do your inner join. The cons of it can fail. If your file size is huge, this will crash. What is the other option, or let's say the optimized option, which was the option number 3 here? This one, we already have the country capital in the hash map. All we are saying is read user country line by line. Take the first line, do a lookup in the hash map, which is in RAM. You are reading from the file, just one line in the RAM, doing a lookup on the hash map in the RAM. You get an output, and then you keep on doing it and pushing it back. So you're displaying it continuously. It's not like you are caching it somewhere. You do the lookup, you generate that output on the screen. Then you do the same thing, you generate that output on the screen. Right? Now let's go on to the class part of it so that you can appreciate what has been done. So first of all, we have defined certain variables like base path, absolute file path, blah, blah, blah. Right? Yes. So first of all, because the base path was there, we are saying that, hey, sorry, and there's a constructor for this. What it does is, it simply says that whatever base path that you provide, it will just set it to the instance variable names here. All right. Then you say create folder path. It just takes the folder path. First of all, it goes ahead and creates your base path, blah, 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 and then finally creates the folder path. Yeah, and you can see here, this is the command that we have used. Files dot create directories. So it will recursively create directory till your folder name. Because see, what is the absolute folder path? Absolute folder path is nothing but the base path. So we are assuming somebody has given the base path like /tem, some random folder name here, right? So it just goes ahead, takes the folder path, attach the folder name here. So folder name was like database / user country. So one folder name I have given, it will go here, create that folder. So it is recursively creating / then whatever, some random folder name / database / user country, then the file name. So this is the folder creation. Now we say write to the file name. So just assume the folder has been created. Where the folder has been created? So you can see here, we first of all call the constructor, the base path was given, then we added one more subfolder to it, then we created one more subfolder to it, and then we are saying that set the file name as cucap.txt. The moment you go to generate country capital, sorry, yeah, this right to file name. So we have to pass the file name here. What it is doing, first of all, it is taking the absolute path, which is now pointing to slash user country folder name, right? You attach the file name there. You create a buffer writer. You are getting the JSON data and you are writing the JSON data, the new line, because just again, OS, the file system doesn't understand new, the line is ending or a paragraph is there or a word is there. You have to define it. So slash n is also a character. So you go ahead, write a JSON data and a slash n, and then you keep flushing it. That's how you're able to write the data on the file. And again, this function can be called for both user country and country capital because this is generic. This has not hardware anything. It's just writing a string. That string is a JSON data for us. So it's just going and writing the string inside it. Now look at this function, read files to list. All that is doing is it's going ahead from the absolute path, getting the file name, and then look here, it's just reading data line by line. As it's read data line by line, it is just adding in this linked list, this lines here. So that's how what's happening is it's able to read back data into a list. All right. This user country line by line, same it is doing, it's just going ahead. You give the file name, it's getting the user country, but the good part here, now it is reading the data line by line. The line is a JSON. It is parsing that JSON and getting a user country object. Yeah. And from the user country object, what it is doing is simply going ahead saying that this is my user because I'm iterating through this line. I would have got the moment I use this particular line, what's happening is the JSON is getting converted into an object. So uc.getUser capital is nothing but this part, which is nothing but like this object uc.getCountry, right? And then you do a lookup in the country capital hash map, and then you are able to pass on the capital and you get back the user. So this is the optimized version wherein you read line by line the country capital, user country, and in the hash map already the country capital was present. You are able to do a lookup and then you are able to get the result. This whole code has been just encapsulated. Like I'll just scroll that through once again slowly so that you can just rewind the video and look into what's happening. All right. And then the main function, as we mentioned, you create the two hash maps. You create the folder names, the file names. You first of all generate the country capital data. You read the data into the hash maps. The same thing you do for user country, and then you can iterate through it and perform the join. This is like when you pull data in RAM. The other is like you read line by line the user country, and then you look up in the hash map of country capital, and you're able to produce the same data. Let's quickly run through it and see what happens. So perfect. It says that likely created as /temp user db database, blah, blah, blah. This is the folder name. We can quickly verify that, hey, whatever I'm claiming, it's there. You see it's in this folder. And this is how it looks like, right? Country capital. Similarly, it says that, hey, directory created for user country. So if I go here, expand this a bit. This is how my user country looks like, right? And that's how you get the output. All right. There has been, I believe, for country Germany, we have not defined the user. That's why it's coming as null. So because CC2 should be, yeah, that was the fix. User country is user 2 Germany. Set user CC2. UC1. Set user 1 India. Let's look here. Append is true. So it is appending. What it is not doing is it's not deleting. So what I have to do is I just have to go RM. Now I think it will do the magic. Yep. So now you have the right output because I was not deleting the file. So the initial content was there, and that's how the challenge was coming up. Great, folks. So again, folks, just key takeaways. Your database, end of the day, is doing just file processing, serialization, delegation, and a client-server program. Your Spark is doing the same. Your MapReduce is doing the same. Your Kafka is doing the same. So if you have your basics correct, these topics are just abstraction, and you can cover this topic in less than a week. That's all it requires. And definitely, see, there will always be a let's say the learning curve wherein you will learn the APIs and how to do it and the best practices. But I'm saying from the mental model perspective, it is less than a week's time and effort and understanding to understand distributed processing. If your fundamentals are clear, the whole of distributed processing is not more than a week of effort from your end. Thanks a lot. Thanks a lot for going through all my videos and look forward to you in the next session.